to continue with our module 2.
Yeah. Okay, can you hear me better?
Can you hear him better?
Yeah, that sounds good.
Okay, yes. So I'm presenting for a task 2 that is led by Professor Liana Cipca, the charging infrastructure and energy system in the interdependency. So it's not clicking. No, it's not. It's not moving.
1 second.
Oh, yes. Okay. So as we discuss, I look at the Great Britain annual emission, and I saw a nice plot about how it's going lately, referring to the level of 1990. So from the road and transport, we are not doing much better. We're still going a little bit better, a little bit efficient, but not so well. But on electricity, and then I was very happy about that.
Sorry.
Oh, thanks. Okay, I forgot to check that. Okay, thanks a lot. So the electricity, as an electrical engineer, I was very happy to see that the renewable and all the implementation of the new power technology is making a big effect on producing electricity as impact of CO2. So the idea of decarbonization is actually trying to move the advantage we got on producing electricity with a lower associated CO2 to the transportation, doing several actions. Electrification of railway, for instance, or the next step is the road transportation. So the challenge is not so easy. As you can see, the electricity market, the network is very, very complex. But then it's also complex how to model in the interaction between the electrification of transportation into the network. There is not only the assets of the network, like transmission and distribution lines, but also the generation assets are also dispatched and also activated or deactivated according some economical financial aspects. So there is the electricity market involved. There is some aspect about the resilience of the network. And so it's very, very complex. But as engineers, we try to break down in simple steps, try to isolate what we can model and try to use different technique, like in our case, some superposition to try to build up a more complex scenario. The part of road transportation, the key drive is the big role of batteries, high efficient battery that are able to have high density. They can survive a tough life of charging and discharging very fast. And also to try to find new functionality of electric car, like a vehicle to grid, that actually are helping the network when they are not in use and they are parking and connected to the system. So we'll try to look at a little bit of these aspects and how we can approach this interaction. So first of all, from the Great Britain transmission distribution network, we can have a look of the distribution of the high voltage line, 400 kV to 275 kV line that are our transmission level. Then we can have a look. I try to look, unfortunately, with the dots, big looks much more numerous, the electric charging point for personal vehicles along the UK. It seems very populated. If you have an electric car experience to drive, seems they're never enough, or when they are, maybe they're not functional or they're not available because somebody else is having a long charging before you and you need to wait. But so the charging point, our key connection point between our network and the road transportation. So when we are speaking about road transportation, electrical vehicle, which kind of vehicle we are looking? We can have a nice electric vehicles, like we saw some example and early model of electric vehicle more 100 years ago, but also light-duty vehicles, heavy-duty vehicles, buses, and even trains run by battery, not only by a continuous connection. So what is the step to try to make these impacts not only on the current situation, but try to estimate what will happen in the future years, either for the network, either for the electrical vehicles? So the first step is to try to understand how this interaction can happen. So the charging infrastructure is the first point of connection between a battery operated vehicle and the network. So we need to try to classify what is the possible type of charging point and what will be a possible size. What are the possible locations that will be developed where they are and where will be more possible to be present. And then try also, because we want to know not only what is happening on the peak demand, we usually, electrical point of view, in a specific time of the year when the maximum request of electrical energy is peaking, but we need also to know on daily basis, on hourly basis, what is happening in the fluctuation during the day. So we need to know how many users and which kind of connection they require. So we can have a look and say, okay, we are going on motorway, probably you will see the first type of charging station, a cable connected. Can be a low power at home, if you are lucky to have your driveway of the possibility to have your connection, or a higher power in a service or public car park, or even in a working place. The other type of connection is using a pantograph, and usually is for public transportation buses that can use the charging time, the time that actually they are waiting at the terminal stop, waiting people to enter and to start, so they can use that time, very useful to charge their battery. Another way we are able to do also using no cables. So we are doing like we are doing our mobile wireless charging. You just put the car on top of a transmitter and you can recharge. Some applications are thinking why we can limit this charging without wire, only on static condition. We can do it even when we are driving. So it's possible to extend the range of our car, and somebody even making some ideal expectation that we can even reduce the power battery installing in the car, because meanwhile we are driving, we can extend the charging, keep going multiple points, and so it got a very optimal efficiency. Another idea that was going very slow and nowadays recently is going much more on is the battery swap station. Practically, you arrive in your station, there will be a device or some operator will take out your old battery and will install a set of new batteries. And we'll try to see what these are, usually the customer and the expectation on this. So for commercial vehicles, we need to look at something much more powerful than the normal charging station that we are expecting to charge at home. So they start to call it megawatt charging station. So this is one of example. A company, Highlight, will create the power unit that is able to deliver up to 1.5 megawatts. That is quite significant power. And then there is the satellites where actually you connect different vehicles. In this case, will be commercial vehicles, heavy duty vehicles. So they can be up to 6 per one power unit. And they will be in commercial, on sale by 2025 or the end of 2024, they expect. So another example that, because we are connected with Birmingham, I spotted that they got a very nice new entry of 6 buses that are from Volvo, that they're actually using the traditional cable connection and the pantograph, and they will run. So I thought, okay, which kind of charging power is 450 with the pantograph against 250 with the charging power cable? So the pantograph got an advantage of giving a much faster charger. So even if he's charging for that 5-10 minutes, is a significant amount of power that can be provided, and looks quite interesting also the example. So the other way to connect is the wireless. So it's useful for all the application. So I try to look at some car like Nissan. Yes, I didn't put in big, but on the reference, the Nissan was saying, okay, it's very nice, the static wireless charging. You arrive home or you park on the street, you don't put any cable, you cannot trip over on the cable around on a street parking. It would be not possible because it will be a trip hazard, but you can park simply and charge. But the efficiency is very, very affected by the alignment between the transmitter and the receiver. So they said, okay, especially on the new car, we want to pay a little bit more for advanced parking system. What if we had in the advanced parking system is not just parking itself, so we avoid to do a reverse of all the maneuver, but it can also try to target the alignment. So it's automatically alignment between the transmitter and receiver. And so we can achieve between 80–90% all the time, thanks to this option. In addition to the street parking, this is working very well, the static for taxi. So if you see, when you try to the city center to take a taxi, normally they are queuing in a specific area. So there is some project, one example in Nottingham, where they installed the wireless charging system on some part of the fleet. And meanwhile, they are waiting the customer, they're able to recharge their battery. And this is very convenient because they can move, another taxi driver can jump in and it's very smooth and very convenient, but maybe more for the taxi than for us as a personal user, and not so good maybe for a truck. So every solution is more optimized for the specific vehicle and typology of use. Another aspect of wireless charging is the dynamic charging. And it's very, very nice, the idea. There is, the efficiency maybe is not so high as the static charging. The big problem is we need to do some road works. We need to install, I found a picture of these coils along the network, the road, create an electric network to power these. And as soon as you travel and then negotiate, probably negotiate the purchase of charging, this will be not for free, you will be able, but the cost is still very high. So is this the solution, or is one solution that is very, very costly? The electric trucks with replaceable batteries, they can change the batteries in 5 minutes. That was so practically what they've done. The idea is, I got the electric truck, I had that box on the back of the truck that is indicated by the orange arrow, and that is containing the batteries. Then it's very easily to swap all the container or the battery pack by the red arm, automatic arm. In less than 5 minutes, it can change the battery. This is very good for heavy-duty vehicles that got a very specific route. You can plan very well where there will be this exchange of battery. And I was looking for the statistic, the recent statistic. They said 50% of heavy-duty vehicles sold in China are with replaceable battery. So it's something that we will see coming on more and more. From my point of view, I always see the drawbacks of this application, that if I come in with very nice brand new battery and I swap with a fully charged old battery, and I will keep going to receive old battery, how I can assure that I got the same range? So this system works as well when you got a different type of economical framework, where you not own the battery, but probably you rent the service of the battery and is owned by someone. So for you is the service of having charged battery, not owning that part. It's just a little reflection. But so typology size, we did a quick overview. Now, how we can define the exact location of a commercial vehicle charging point. At the moment that we saw in the map, there is a lot of charging point for vehicles, but the new generation for commercial vehicle are not yet defined. So there is a big challenge to know where will be this charging infrastructure. So first of all, the focus I was trying to look at is road transportation commercial vehicle. They will be mostly on the depot charging facility. So the owner of the transport will install where there is their depot, the charging that overnight can able to charge. And a lot of these can be also applied to things that we already see around in Cardiff. Like we were discussing with Liana the other day, DPD and Amazon are having a fleet of electrical, 100% electrical van, and they are charging. and they're charging on the depot overnight and then working on the delivery during the day. And this is kind of commercial vehicle that are doing quite a lot. However, even the destination point, if for instance is a port or other elements, so you're arriving and you're waiting the load to be passed to the truck, it can have an opportunity to have additional charging. But then, if it's a long haul, this driver will drive along motorways. So another location that we need to take into account is motorway services. So I look and I found a nice map of US. They were showing the volume or the prediction for 2050 of the trucks on a national highway. And I saw that Chicago seems the start point of this long route where everything is going. So on Chicago, they are very well located for the next generation of heavy duty charging point. So they were expecting where there is high volume, a higher need of point of charging. And so for us, from the network means higher load, peak demand. Then I always, little bit, because I didn't try in a truck, electric truck. I try the electric vehicles. And I was wondering how much is the actual range. So I look at different manufacturers that are offering a quite similar at the moment range expectation with incoming much wider range with adoption of bigger battery. In this case, in 1 or 2 years, there will be available battery capacity of 728 kilowatt hour. So they are quite big. So the first point was, okay, this is the range when the truck is unloaded, is partially loaded or fully loaded. And I found some data declared by the Scania about this kind of variation using the same top battery. They can have 600 kilometers, 550 or 375. Same driving condition, just changing the load. So I calculate the efficiency. So we can see that it's 1.21 kilowatt hour per kilometers, up to almost 2. If you're looking at some studies, the reference of electric vehicle for the heavy, the commercial heavy truck is 1.15. So we can understand that sometimes some range are expected to be when the truck is coming back, maybe unloaded on that efficiency. However, a little bit lost on this range, there was a very good statement from the fact that, at least in Europe, there is a regulation that forces the driver to have maximum 4.5 hours of driving step, then have to rest half an hour and then continue. So looking at 4.5 hours, let's say 85 kilometers per hour, if there is no traffic and they're able to go continue, they can roughly make 360 kilometers. So if a truck in different condition is able to provide these 360 kilometers and then able to stop to recharge for additional part, is able to have long haul trips. And I look at the statistic from the traffic data that at the moment, the average speed is around 54 miles per hour on the motorways, dual carriage, equivalent to 85 kilometers per hour. So we are okay. I try to look as well the US, and the indication is similar average speed on the highways. So we got a similar condition of range. The only problem is I don't know the average hours of driving in US, so it's probably needed more investigation to understand how range will impact on the current driving cycle adopted by US trucks. So the usage. So I found a very nice paper that actually was recording the charging for personal electric vehicle, not only on the 24 hours, but also on different months. And we can see immediately that because the charging seems more adopted between 8 to 5 p.m., this suggests that there was some incentive for people not to charge at home, but they're actually charging going to work. So charging at working place. And this is another option that can be for the personal EV. Then how we can look for the trucks. So most of the volume over the 24 hours in UK is between 5, 6 is getting, there is always some movement, but mostly on 6 o'clock to 16 in the afternoon. So we know that will be a lot of movement. All these trucks moving will require some charging. So we're expecting during the day quite a lot of them stopping and recharging. Some study as well, they look where they will stop on the motorway. So they provide some indication of map overlapping the position of the motorway service with the density of the flow on the motorway. So we can see that there will be some direction that will be departing, for instance, from London, going up to north, there will be very high demand. So there will be need to be more charging point. And for us, is impacting the network, asking more peak demand, but also more energy along the day. Then, if we want to try to have an understanding, for instance, seasonal pattern or other variation of typical vehicles, we need to try to have a little bit a better understanding how the battery range is affected by other conditions. Driving condition, ambient condition, route condition, even this fact that it's not a flat route, but there is some uphill, a downhill, it will impact the battery range. So a good way to approach this is to have a good digital twin of the vehicles type you are trying to model, and try to implement all the aspect of this vehicle on the different condition. For instance, speed, acceleration are all very big impact on the battery, and also the payload, like I mentioned before, and the temperature. So we try to make a big analysis of the electric truck or the vehicles to try to get at the end a values spread over the 24 hours of power, the location, and the energy will needed to cover all these battery. But then how we can implement this requirement into our network. So we need also to have not only the network and the power plant and possible storage that is present now, but we need to start to make some prediction how will be the network in 2035 or 2050 to correlate with the needs of electrical transport. So, for instance, in Cardiff, we got the high voltage network of all UK, and we are able to try to extrapolate, assuming some modification in the next years, which kind of power plant will be in function, which one will be decommissioned. So we are able to represent. And this was a little bit an old approach, but even the network is changing quite a lot. I managed to have pictures. A picture of the interconnection using HVDC link. So we are very, very strongly interconnected with multiple countries. And this interconnection is bringing a consistent amount of power. So when we need to do the model, we need to start to take into account also this part of the network, so the HVDC network, that in the past was a little bit relegated to, yes, exist, is just a little percentage, that's it. Now is not anymore. So how we can try to have prediction? In UK, we got a very good opportunity to look at what the National Energy System Operator is publishing as a future energy scenario. So it's giving some perspective. So recently they create a pathways. So they try to make 4 possible paths to reach net zero. Actually 3 paths that actually reach net zero, and 1 that if something go wrong and by 2050 we're actually not able to reach net zero. And the other 3 net zero pathway are a little bit balanced between how much hydrogen will be in use, how much electrification, and also how much other system approach we are implementing. So they are able to give some indication on if in the case of this holistic transition, so it's very strong electrification part, to do some energy requirement along the years. But then the big problem is not only the transmission network. We need to look at also the lower voltage level, so below under 32 kilovolts. That will be the one that will be more exposed to all these impact of the charging. We got National Grid that is taking over this 4th zone, and we are able also to interact with their data source and their prediction. So we can tailor or compare our model with their model and try to see how far we are or which kind of hypothesis we agree or we disagree. So I pick up an example of the expectation of annual peak demand at Cardiff East, a substation that we are being served without, maybe most of you don't know. I know well because we are bringing the student to visit this substation to show how it works. but is 20 megawatts. In 2050 is going to 80 megawatts. And this is just to one small area that you can see in the map. We need to extrapolate to find a methodology how we can create a prediction and to have a prediction that is function of the area, function of the capability, also of the people, how many people will start to buy electric car, commercial vehicles, maybe the charging point with the electric vehicle, commercial vehicle will be not spread all over this area, so will be concentrated. And we need to try to find all these requirements and how much the network can provide and how much need actually reinforcement, means investment of new assets or new methodology to run the network. And I had also a no-road transport, if I got some, that I found very interesting, that even train on battery are in use since 2016 in Japan, and they were actually quite efficient to reduce CO2. Another case that is a little bit, another good example how this electrification is not only battery, but there is a mix between hydrogen, battery, and actually traditional electrical railway. And this train actually able to provide all three characteristics. Is able to use a pantograph to run and move using the electrical system provided by the conductors, the catenary curve. They can use the battery and charge only at the train station when they are stationary, or using hydrogen as conversion in the fuel cell and using the electricity. And the interesting part is the performance. It can travel up to 150 kilometers as battery pack. So it's giving the flexibility to interconnect part of the network that can be economically electrified with part of the network that actually, because of not the high volume of passenger or freight, is not convenient to invest in a electric system with catenary curve. So this will give a very good flexibility and choice. In UK, we got this dual system, and is estimated by IT that if we are using this kind of system, we can save 12 million tons of CO2 over 35 years period. So it's a significant impact. And just to give a little bit, despite maybe as a volume will not make a big change, we are speaking about 100 kilowatt hours. There is some tentative also to make a ferry or a small boat for a passenger using battery. So this is an example that is in US, has been done and in collaboration with a UK company, BAE. Then I finish trying to give a bit back, a little bit local. So we look the exploration of road transportation. I saw that they are stating quite a lot Cardiff buses, and they put some data. So on 2022, the buses were not too many, but they managed to have 1 million kilometers. But now at May 2024, they already have 20 millions, and they're investing and continuing to investing. So this is starting to become, for the infrastructure, started to be significant because these buses need to be charging. They are become number. And they need also to maybe fast charging and depot charging. So we'll now something interesting to see how the network, our local network, will respond to these needs. And then I look, thanks to a pub that was posting a lot of old picture, I discovered that before I was coming, there was electric vehicles that we are always looking, and nice pictures of different trolley bus. And I cannot see now, but the funny part is they said that it was inflexible and slow at junction. So the trolley bus was taken over by the engines. And I always wonder, some city still use trolley bus, and is another things that maybe we can open, maybe as a suggestion, a question, would you take a trolley bus? Thinking that this maybe is an alternative solution if there is difficulties to have all the buses by battery. We can have alternative systems that are actually not so new because was running, and they don't need trucks on the road. Thank you.
Thanks, Maurizio. Just opening up any questions in the room here in Chicago.
You want I pass?
Maurizio, we have one question here in Chicago.
Okay.
Hello, Professor.
Okay.
Hello, Professor. Thank you for your presentation. It was very insightful. I had a follow-up question for the question which was posed in the previous presentation. As it was as we were discussing about equity and sustainability, wherein if you are to make the EVs more EV technology and the cars easier for the public to buy, we tend to go towards making technology unsustainable, because as consumption increases, we have as the efficiency increases in terms of technology, the consumption also increases, and it creates inefficiency. I think it was put forward by Jevon. He was an English economist, and he put the Jevon's paradox in the 19th century. And as we are sitting here in Japan, there's a bi-weekly motor show happening wherein Toyota is trying to display their new technology, which is the fuel cells EVs. They're using hydrogen as a alternative solution for batteries to charge their EVs. So I wanted to know if we are relying on the supercharger network or electricity to charge our batteries, how would different technologies like the hydrogen cells batteries can be implemented for the long term, and what would happen to the existing infrastructure, because it would be unsustainable later on if we are moving forward with a different product?
Yes, it's very good point on this. The part of I can answer is I'm not expert on hydrogen, and there was surely here in the team people with much more expertise. But one thing we can observe, the technology is there to run a truck, a train, and different elements. The problem is the infrastructure and the cost associated. So this is a variable that it will impact the number and when will happen. So when we're doing the evaluation of the network, this is a part of the variables that we need to take into account if we are going to EV or only, or we are going to EV and hydrogen. I'm not supporting one on the other. Actually, I've always been skeptical. If we need to change cars from combustion to electric, why we need to go to the same model, big car for everybody, when we don't need big car all the time. So maybe we should start to think, maybe we need a small car, other system. And I always see the comparison with the new trains, electrical trains. You can drive as much as you like, but you need to stop by a range or even to have a coffee. With the train, you can do long range much easier. So it's opening a lot of discussion that are behind my knowledge, but it's a very good point. Where is the limit of the technology? And where is also the limit where we should aim for? This is an open question that it will be very interesting to investigate.
Yeah, Maurizio, I'm sorry, we should cut off here so we have time for our break. So if there are additional questions, please throw them in the chat. We will do our best to answer them in the meantime. But we are going to take another 5-minute break, so please feel free to stretch your legs, use the facilities, and we will come back in 5 minutes, 12:25 Chicago time. You can see the other times on the screen here. Thanks, everyone.
So Sam, we have one more question, a very eager person here to ask a question. We could just wait for that, if that's okay. Do you mind? So go ahead.
Yeah, sure.
Just one more.
So in regards to the trolley bus question, that was a very interesting discussion you've made. We actually have trolley buses in my city, and we're fairly unusual in that rather than cutting down our trolley bus system, which we used to do in the past as well, just like other many cities in the world, unfortunately, we are actually trying to slowly expand our trolley bus network in addition to buying new battery electric buses. So we've recently, about three years ago or something, we've recently introduced electrified, and when I say electrified, I mean putting overhead wires on the road, a bus route. It's a fairly important bus route. It connects a major hospital with a city centre. And so my question is, could trolley buses be the future instead of battery electric buses? Because you don't really have to worry about the back. So yes, there is the disadvantage of having to spend all the money on putting all the overhead wire infrastructure, but then on the other hand, you don't have to worry about batteries and the future long-term impact of batteries.
Yeah, a good point. But in my opinion, I think it's wrong to find a solution. I think we need to look at the portfolio of solution. So the trolley bus and battery bus are like a portfolio that need to be expanded and try to find the optimal balance. But to go for one only solution, it will not fit all the cases. It will be not an efficient solution. So I think the big part and the amazing part to be now is we can try to draw what will be in the future. And all of you actually design the future. So you have a big step ahead of you, but it cannot be, I think, one solution. It's a portfolio solution. On this, I'm very convinced.
That's a good point. Thank you.
Thank you very much.
Thank you very much.
1 minute break.